So now members, in this example, we are going to see how we apply the Newton's Raphson method into the flowcharts. So the question here is, determine the iterative formula or finding the fourth root of any number n. Draw a flowchart that reads n at the initial approximation x0, computes and prints the fourth root to 3 decimal places. In simple terms, they are giving us the tolerance. Then perform a dry run for n is equal to 150 with an x0 equal to that. In simple terms, we know how we need to get this formula. We know that we need a function f of xn. So we say let, we can start by saying let the number that's giving us the fourth root be x. Now we power for both sides of our n. Now we equal to x power 4. We take this beside. So we have x4 minus 10 equal to 0. And from there we say let our f of x be x power 4 minus n. So after that, we need the derivative. So in a differentiate f prime of x, we get this one will be a constant, it will go to 0, then this will give me 4x power 3. As simple as that. Remember, I need to evaluate them at at xn. So f prime at xn is going to be 4x cubed n. So I evaluate this at f. So that our xn will be x4n minus n. Substituting into this formula now, my xn plus 1 will be now xn minus this now, this formula here, x power 4n minus n, the whole over the derivative, which is 4x cubed n. So after doing that, what happens? We are going to cross multiply, and if we cross multiply, is that we shall be having 4x power 4n, open the brackets, x power 4n, then plus n, the whole over 4x cubed n. And to simplify that, is that now our x n plus 1 is going to be, when we simplify, is that we can remove 1 over 4, then remain with inside. You see this one is going to give me, it's going to give me 3x power 4 n, if you subtract, then plus n, the whole thing now over x cubed n. So if you simplify, so our x n plus 1 is going to be 1 over 4, now into, divide it here, divide that xn there, shall be having 3xn, then plus n over x cubed n. And that is going to be our iterative formula, which defines from n is equal to 0, 1, 2, and so on. So now we have generated that formula. Now when we come part B, they are telling us that draw a flowchart using n. So now, to draw my flowchart, now I think this is space will be now for the flowchart. So our flowchart. So what I'm going to do, we do the start stage. This is my start stage. Then after start stage, we are going to read. Remember, we are starting from n is equal to 1. So from here, I'll say we are going to read our n equal to 0 as the starting value. Then from there, now you need a ruler. But I don't know where my ruler is. Anyway, we can leave that. So you bring this, but let me first check for that ruler. Now we come to our read parts. So here, remember, they're telling us that this one should be read. Remember, they're telling us that this one, the fourth root that reads a number and the initial approximation. So here on the read part, we have a read. We are reading n and the initial approximation x naught. after doing it like that, now we are going to come, we are feeding in now the information. The information is the formula that we are going to use, this formula here. So then you draw a bit bigger. Then xn plus 1 will be equal to 2. Now you put in this formula 1 over 4 into 3xn plus n over x cubed n. You put in this formula, then you cross the whole of this. Can use a ruler or not. Okay, now after doing that, what happens? We come now to the decision. Now they're telling us that to 3 decimal places, meaning that our total is going to be 0.5 times 10 power negative 3, where our n is equal to 3 decimal places, and so this one is going to be 0.0005. Then we come and ask ourselves, so after getting these roots, you ask, is the error less than the one we can tolerate? So you do that decision part. Now you ask yourself, is the modulus of minus xn less than the tolerance 0.0005? After asking yourself that the decision, because if that is the case, then we are almost there. If here someone says that the tolerance is a no, if this is a no, then it means that now we need to do our n again. It means that now we change the n we used initially there. So it means that now we can find that now our n that we had initially, we are going to add a 1. So our n, add a 1 on our n we add. After adding 1, come and substitute it. Now you are going to come and put the n now in there. So after putting the n, now what happens is, if the decision is a no, it means that now that is not the better route that we have. It means that now we shall go the next route. Remember, when the route is not this, you go the next. So it means that now after that, it means I'm going to read back now my route to the read here. So that I read this again, meaning I get the other value of n. So now we read I put it back into the processor like this. I put it back into the processor, then they process it. If it's not the best route, then if it's a no, that is the case. What if it's a yes? If it's a yes, it means that now I'm going to print. I told you to print what? I'm going to print n and then xn. So here, if it's a yes, I come and then I print. All right. Print. You are printing now that root and then the n. Okay. Okay, so after getting that, remember after printing, the last stage is to organize ourselves and get back home. So you do what? We stop. So you organize yourself and go back home. So that's the flowchart. Now, allow me to do, this was part B, then my part C, allow me to do my part C here. So do my part C there, they are telling me that draw a dry run, perform a dry run there. So I'm going to do it here. Allow me to do it here, around here, such that we can always be able to see what is going to happen. So from there, it means that after that part, you come to this part. So now, I'm going to have my n. Remember, we start with n. So our n is there. Then we come to x n, our x n, the naught. Then you come to our x n. Before you come to x n, that's when you go to x n plus 1. So I give this to x n plus 1. After getting that x n plus 1, I want to check the tolerance is x n plus 1 minus x n less than 0.005. So that's what we are looking for. Then you cross. So now, the data that now from here we are going to use our n. So we are using our n as 150 and x naught as 3.5. So what are you going to do? Now, you substitute them here. So when n is 0, we have x naught equaling to 3.5. So our x1 will be, remember now our total is 3 decimal places, so meaning give this answer to 4 decimal places. Now you press that with the calculator. I think I've told people how they press those things on the calculator. But now n, which is 150, divided by x power 3. So when we put in the 3.5, the answer we get here is 3.4996. You see when you subtract that, from that, we are going to get, okay. So when I subtract this from this, you see if I put here my 3.5, you subtract 3.4996. These are zeros. You borrow. So we are going to be adding. So our, this one, is that our modulus here, I mean our error here is going to be 400.0. So that is our error. So meaning here we are adding to just perform only once because the root is just there. The value they gave me was accurate. So it means meaning I had just performed it to that case. So meaning that is my answer. If it wasn't the answer, because it's that this one is less than this. If you subtract, this will be a 4. Remember this will be now 9, 0, 0, 0, then 0, which is less than the tolerance that you are having. And if this was to 4, then you will continue to x1 and x2 and so on. So now I close my table because the tolerance, if it's yes, now this one is a yes. If it's yes, print xn plus 1. Mean that what I'm going to print is this. Xn plus 1 is going to be 3.4996. Now they want us to 3 decimal places, which will give to 3 decimal places, and it becomes the original root. Xn plus 1 becomes 3.5 for decimal places, and we are done there. So now, for you to try when x naught is 3.3, and then you try those values. If it's not, you add a 1. If it's not, you add a 1, and so on. Anyway, that was the idea of how you can handle this question. I think we have exhausted all the ideas. See you there.